So in R, a histogram is obtained using the code below. Okay, so you see histogram is the font themes are different, right? In other words, this one should always be in Courier New. It makes it, especially when you have results, and let's say there are numbers, it will arrange it in order. If you put it as Times New Roman, it will just make it haphazard, okay? So your results and codes should always be in order, in Courier New. So, let's say, let me get, let's say, mass. And let's say psych. Okay. So I can, let's say I display an erasure. Okay. And I want to show these results. Okay, so I copy this, I paste. Okay. Okay, so ideally this should be in Courier New. It will just make your work just like what you see in a book. So if you take an our book, this is how you do it. So if I'm writing here, the result is shown below. You realize that I can distinguish between the write-up that I'm doing from the code or results I got in now. So please take note of that when you are doing it. Don't put one. Let me just do, let's say, Times New Roman, which is what we normally use. You see the way it is. You won't see which one is code, which one is, yeah. So if you check all let's say the book, okay. So this is GG plot 2, the book itself. So when we go in, you see, there's a difference between what? The codes and the write-up. You get it? So what you see over here will be just like the Courier name that we've been using in so please take note of that. In your assignments, you So that even brings me to what I want to do. So, what is the ggplot2? So, yeah, so I was showing you the assignment, but we will come back to all this and try to understand the way to approach, what do we call it, plotting in the context of ggplot2. So this is not nice. So what we are saying is that you can get all of this, but make sure that in between this you put them in Korean, yeah, and it makes it nicer. Okay, so that's it. Any question on this? Okay, so we can move on to the ggplot2. Okay. Now, so as I said, at the heart of the grammar of graphics is a package called ggplot2. So ggplot2 is based on what? The grammar of graphics. What does this mean? Well, it means that instead of always putting everything into one, then we can build layers. Okay, each layer, and then we add on to it and a plot, so we can get a point, we get legends, we get colors, we get all those things. So ggplot2 puts them what in different categories. So for example, we have the usually. So if okay, let me display the cheat sheet. Is it here? Not this one. Data visualization. So I've sent you this over there as well. So look at the way ggplot approaches the basics. Okay. So usually you have a data, right? Okay, like what we've been dealing with, the anorexia data, this and so forth. So the data will have variables. So the variable f, m, and a, right? Okay. Now, so when we want to get a graph, we will use the geom to match this. So x, later on we'll call them what? Aesthetics, right? Okay. So that will match us. It will help us to know what is x, what is y locations. So the x is now our f, y is what? A. Okay. Then we need a coordinate system. So when you have the data, you add the coordinate system to it, then it produces a plot. Is everybody okay with this? Okay.
So it's showing us the axis.
Yes. So we have a data set. For example, the anorexia data or the fish data set we've been dealing with. And I want to get a plot. Okay. So I have to check within my data, what is it that I want to plot? Or there's certainly to be variables. Good. So the variables, I'll take the geom will match my data to the variables. Or in the other words, my x and y locations, if you have z and so forth. Okay. Then you have a coordinate system. So the coordinate system is a graph that you are going to superimpose this data, which you are transforming through your aesthetics or the geoms to that plot. So if you put them together, you get a plot that we have over there. So it said that to display values, you map values in the data to visual properties. So once you take the data, we have to match it to visual properties of the geom. It's just geometry. Remember, my geometry is about graphs, right? Okay. Now, so aesthetics, like the size. How do we want it to be? Color. Our x and y location. So if we come down here, we have what? Did I start? Okay, I have started. We have the data. The geom is what? X is f, y is a. Now color is f. So we can use the same x to color it. If we have groupings within it, it will give everybody the same. And size is also a.
So it means that color f. So it means that color the f.
No, it will use the divisions within the f to color. Remember, we can use 1, 2, 3 to color.
Yes.
Yes. So when we take an example, you will see some of these things. But essentially, you can use the same data to get the size, the color, and so forth. Remember, we color and then we give legends. It's the same principle. In the coordinate system, you get your graph. So eventually, a complete template below will build a graph. So you see, we have ggplot of the data. So you take the data. So you see now we are breaking it into different charts. So I take the data. Then I use a geom function. That geom function will now map my aesthetics. Okay, x and y. I can add the statistics, positions, coordinate function, facet function, scale function, and then teams function. Okay, all these, as I said, not required, sensible default supplied. Okay, so we don't need to do all this, but the first two will give us a graph usually. But sometimes you need to go on, if you are advancing to it, then you go on and get DIMs and so forth. Okay, so for example, this one, if you look at this one, it's a data set, which is the MPG of at the miles per gallon. Then the status, you have X and Y. So this should give us a plot quite easily. Okay. Yeah, so, but you can also use what we call KPlot. So in the ggplot2 book that I've sent you, you realize that we start with the KPlot. That also do an excellent job, but you implement the grammar in its totality by using a ggplot. And so the KPlot is less like an abbreviation of it, a compact form of the ggplot2. So you start with that, and then when you master, you can now go to the ggplot. But whatever you can use the ggplot to do, the KPlot will also do it for you. Just that is a bridge between the base and the ggplot2. So sort of. Okay. So it is telling you that what we got over here, we could also create the same thing using what? The KPlot. Like this. Okay. Some of this we can just take like this and then go back here. If I ggplot2, yeah. So if you have installed it and I need more space, let's see. Okay. So you see the plot, it gives you the plot, but it is just giving you what? Just the we haven't put the points in it. Okay. Now, if I take this and I do plus geom points, and I run this, it gives me the, so you see you can add layers to it. So the first one, what I did was to get what? The area, okay, or get a place, the scale, my aesthetics plotted, but I don't have a point in there. So this one, the geometry will now link the data, superimpose the data on the plot. I can do this in Bezier by doing plot. Then instead of type, you remember the type, P is points, B is both, L is line. I can put type is equal to N, and then that will suppress no plot. So it will just give me my X and Y, and then I can use points to superimpose those characters on it as well. So this how far, and you see this one, you don't need to do the par. Do you remember we were using par to set the graphical parameters, the spaces? You see this one, it filled it by itself. So that's the beauty of the ggplot2 as well, that you don't need to do so much work. That's why I don't start with this. If I start with this, you won't even know what par is. You see, at the base one, you have absolute control over whatever you do. But here, you can have control, but most of them have already been done already. Okay, and so forth. So let's copy from that. This one, if you have to write, it takes time. Yeah, and the mistakes here and there. So just know the structures. If you want to do it, you can always copy the structures and be filling it. Yeah. So our duty here will be mostly be copying the codes, and then we are getting to know what this is giving us. How do we change it, and so forth. Okay. Now, if you look at the second one, is a KPlot. So the ggplot, as I said, is a full implementation, but we also have kplot. So if you see kplot, it says what? Quick plot. So that one is that's just like a wrapper for the ggplot. So it says that it's now deprecated in order to encourage users to learn ggplot. So when they started, there was a break between, because it's based out, if you want to transition to ggplot2, it's a bit, I mean, most people who are, if you have so much command over the base, it's difficult. For example, I hardly use ggplot2. Because in the base one, I can have command on whatever I want to do. Here, you're a bit restricted some way because everything has been programmed to do it this way and so forth. Yeah, so they created this so that it's a bridge between it. So now you see that it's telling you that it's deprecated. It means that it's suppressed a bit, but you can still use it. So let's see how what it will give us. As the so okay, so yeah, they have okay, so they've actually deprecated. Okay, we need to add points in it. So that one, you see, I could get ggplot2 with just the data and the aesthetics. But for the kplot, if I don't add the geom part, okay, so what do I mean? Let me go back here. See, here, this is the data, this is the aesthetics. I did not add points, but I was able to run this alone. Do you remember? But I added the points or the geom, and then I was able to get the required plot that I wanted. Okay, so let's say if I want a box plot, whatever, if I want to add a line and so forth, I can do so. This one, if I have to do it, I need to supply everything. You can't do it in parts. Remember, it's like a wrapper. So here I need to call geom, right? And then the geom, I can now say points before it, and that's what we find over here. So points, okay. So it says it creates a complete plot with all given data, geom, and mappings. If you don't supply all of them, it won't work. Okay. So we go back. It's points, no points. Okay. So if I do this, it's still not even letting me write it. So maybe now you can't even use it at all. Oh no, I need to provide X and Y and not in aesthetics. So okay, and it has to be, this should be the last. So you don't need the aesthetics in it. Do we have this? Okay, yeah. So you get the same thing. If we go back here, it's the same. Let me clear this. Yeah. So it's the same. Nothing really changes. It's the same. So you can copy from what I sent you, just so that we don't waste much time. Okay, so this will supply many defaults for us to be able to get what we want. Yeah. So that's it, and there are so many functions. Here we can save the plot using the gg save. Okay. Okay, so okay. Now, once we are done with that, we can move to the next column to see what the geoms are. So remember, we started with the basics, right? We've seen what the ggplot2 is, and we see what the data is, what geom is, what coordinate system is, what a complete plot is. All right, and then we've seen that for a complete template to build it, we need the ggplot data. Then you need the geom function, and the mapping, which is equal to the aesthetics, and those are the key things you need. The rest are optional, and they are provided with default. Okay. Then we've seen that if you want to begin, just the ggplot, the data and the aesthetics will just begin the plot. You need to add layers or one geom to actually finish it or get the required plot. Is that okay? So ggplot data will get you so that you can read from the variables, and then the aesthetics will now say, okay, this is our y, this is our x. But to get the points, whether it is a bar plot, whether it is a histogram, pie chart, scatter plot, and so forth, you need what? The geom function. So that's the way this does it. And then we've seen the kplot2, which takes everything together to let you do it. There's a function called last plot, which will let you returns the last plot, and then of course you can also save your graph. Remember that one, we can also save it ourselves by just clicking on export, and then we do it. But if you want to use a command to or a code to save it, this is how you go around it. Okay, so let's see when we get to the geoms. Okay, so these are the graphical primitives. Okay, so this one, what do you think this will give us from our discussion? Is it going to give us a scatter plot? Yes, the one I've highlighted. It will give us what? The what? Yes. We just did one a while ago. I just explained it a while ago. It's the same. Look at this one. What did this one give us? No, not just a scatter plot. It just gave us the just the plotting area. Yes. Yeah. Yeah, just a moment here. Sorry, just a moment. Hello? You didn't hear it? Okay, so you see it's the same as that one, isn't it? Yeah. So first, if we are using the ggplot2, then that's the first thing you do. And then you can add on. So if we copy that and we paste in the, we shouldn't expect that we will see a graph with all its all. And for this one, you can also assign it. That's the beauty of it. The base are you can assign a plot. But here, once we say A is ggplot, it stores it as a plot, and then I can add anything to A. Instead of repeating ggplot, economics, and so forth, I'll just call A plus this, and then it will work that way. So that's also the beauty of this. So let's just do this. A and B. Okay. So remember that economics is a data set, right? So it's a table which is just like a data frame, an upper version of a data frame. So it has date, it has PC, pop, piece, and so forth. If we want to know what it is, we type economics, and then it tells us that U.S. economic time series. Is that okay? So all these are real data set that you can use for your thesis. So it's not every time that you have to go outside to go and get data. There are already data sets, real ones, that you can go online and get information about it and be able to describe it in a thesis. Right, so when I was doing my PhD, I used data set in R. Yeah, so A's data set, and it said, I don't know whether I've shown you, but if you type A's, it's in A's 2 data set. It's an Australian AIDS survivor data. So data on patient diagnosed with AIDS before Australia, in Australia before 1st June 1991. Okay, and it's a large data set. So it's a data frame that contains of 2,843 rows and the following columns. So it gives the state, the sex, the dike, which is in most programming languages, dates are written in Julian form. Julian dates are numbers. So you can add, you can subtract, those kind of things. So it makes it easier when you are doing programming to store dates in Julian.
Do you have to download the package before you can?
No.
I'm doing it in
Is. No, it's in mass.
So package the mass.
Yes, it's in the mass package. Okay, so you see, these are real data sets, and they are in books as well. So this one is in modern applied statistics with S. Remember, R was developed from S, and so forth. So this is a data set.
So do they have dates?
Which one?
More current data sets.
Yeah, so this one, I don't know whether they follow them again, but it's a data set. So so look at what I did. You see, there's a paper that looked at the survival rate, right? Okay. So in my work, I was looking at how long you can stay or be alive after you've contract AIDS. But I put in a covariate, and the covariate is based on your age. Okay, so, and I'm not looking at the central part, because when they do their own, they are looking at, on average, how do people live. I am looking at, let's say, how at the tail end. Okay, so is there, let's say, a cap on how long you can stay based on your age? And you realize that age actually plays a role in it, because if you contract it and you're 60 years, the tendency of you dying is higher than somebody who is like 20 years. because at 60 you have other.
The rate at which you can die, like as
Yes, the probability.
okay.
Yes,
How fast
will be higher because you have other other disease good coming in here, which will exacerbate. But if the person is young, they can, the immune system is a bit higher to help them to do that. So, I mean, basically, it's the method that I have developed that I'm checking whether it will work in practice. So it's not. But if your interest is to check when a current data set, then you may be forced to go and get a new data set. But other than that, we want to know whether you understand the concepts and you can apply it. So even if the data is old and you can still apply it and make meaningful outcome so from it, that's okay.
I think the statistics you people.
Yes.
You people rely on. You can. I think you guys are not too much interested in policy decisions.
No, we are. So that's what I'm saying. So on one hand, you want to bring a method that everybody can use. Okay, so if I bring it and I'm able to use it on a data set, then it's okay. That's it. But somebody will apply it in finance or something and come up with something.
So that means people are interested in the theory, right?
Yes, some.
Coming out with the theory.
Yes, some within the statistics there are several branches. Yeah, so there are those who are mathematically inclined who will just be doing those probability aspects and so forth. Out of that, somebody will also take it and implement it. Implement it such as in R, you can use it and so forth. Yeah, and there are also applied statisticians who will just take whatever somebody has done and use it, apply it, and get some meaningful, interpretation from it and so forth. Yeah. So there are so many data sets that are real and they were collected either on human beings, other environmental studies and so forth that you can use quite easily. Okay, so let's go back to this. Okay, then the seals too is a data set. So we can check seals. So it's also the ggplot2 package, right? And it's what vector field of seal movement. Okay, so it tells you that the vector is produced from the data described by Brillinger, this, that, an exploratory data analysis of paths of moving animals. So it's Journal Statistical Planning and Inference, 2004. Okay, and so forth. So this, you see, they looked at what? 1,115 rows and 4. So that is a data frame made up of 1,155 rows and so forth. And the paper, the reference has been given. If you want to read it, you just type this, and I think it will come off. Okay, I think we don't have enough. So forth. Yeah. So that's it. Okay. So if we want to, if we want to see how this head, what head does? It gives you what? The first 6. You can actually put n is equal to any number in there. So then that will give you the number of rows you want. So if let's say we want only 3, so head of seals, and then we put n is equal to 3. That will give us only the first 3 observations. Gives us the first 3 observations. Okay. So that's it. So we know the data, both data sets. And then we know that if we do this, it's going to just give us all a plot. Remember that if I had not assigned it, and I just ran this, what do you expect will happen? Yes, that this will give us the plotting area. So it means that when you assign it, A is now a plotting area. and we can add on to it. Okay. So let's say now, if I take A and I add a geom point, point, and I run this, it will give me a scatter plot. Okay, so that's how beautiful this the ggplot2 is. Are you done? Let's do same for the B. So look at how the B will be like. Yes. If you yeah, so we are building upon it one after the other. Yeah. So we can add lines and so forth to it. Yeah, but let's start with the point, the scatter plot, and then you've been able to produce it. That one too. Okay. So B will be the seals, latitude. Let's see, B plus this. What do we hope to achieve? You see that's not because of the way the data is. And if you go down there and check, this is latitude. I think it's latitude and longitude.
My own is coming like stars.
Your own is coming like stars. Okay, a moment. Dr. Grant. Yes. Evening, yeah, Nisikano. Oh, okay. Mewa down, me try the one. Over what time is it? 7:30. All right, okay. Otherwise, I'm coming to okay, all right, okay. And I'll wait my say, oh, quite no about now. Okay, all right. That's yeah, okay. All right, okay, thank you. Okay, so what this means is that because of the way it is, we have to fit something else. It's not every time that you can get a proper plot. Because there will be spaces in there, but my own is, I've increased my font size and so forth. So you see mine as being together. This is longitude and latitude, so you expect to get points. Every point that you get will be a longitude and a latitude, so that's it. Okay. So that's it with the, at least now we know that we can get a placeholder, and then we can add on to it to get what we want to do. Okay. Now, if you look at what is happening over there, so we are just going through each of them, one after the other, just to get the understanding, and I've given you the book as well. We'll take some examples from it. But let's make sure that we are understanding the grammar and the way plots are done using this. Okay. So let's get back. Oh no, it's not this. It's this. Okay. So here it even shows you what is happening. Okay. So you said the curve. If you want the curve, you need to give it a starting point, an ending point, and so forth. So if you don't give it, you won't get anything. Yeah. So the blank means A plus geom blank means nothing will be shown. It's the same thing. So this is just like running it without assigning. Is that okay? When we don't assign it, so running A plus geom blank is the same as also taking this only and running it. Because at the end of the day, you get a blank plot in there, which you can add on to it. Now, this one, B, you remember how B was. So if we want a curve, that's a curvature, it will end over here. Where the, okay, we can, but we need to take out that as well. So if I take B and I add the geom curve, but here we are talking about curvature, right? So it needs an end, y end, okay, and then x end, and then the curvature is z. Okay, so in this case you are going to get unexpected, something is wrong. Let me see. Unexpected comma. Okay, it has to be on the same. No, I think I did not end. Yeah, so the problem is this. So these are some of the things when you have to copy, and you have to always check. So this parenthesis ends here, so I need one more. Is that okay? So now it corresponds to the curve one before it can end. Okay. So warning, we still have a, let me see. In Junk, a problem while computing excesses while occurred in the first layer caused by object Z not found. Ah, okay. So Z, okay. So Z, we don't have Z already. It means we have to get Z to be one of the data sets. Let me go in and check. What was our head for? Because it must pop out. It was the seals, right? Yeah. So the way. And then we have X is long, Y is lat. Okay, so let's say a delta curvature. If my curvature is delta long, what will happen? It has to be an XY plane, I doubt. Okay. It gives you something like this. So they are well all connected. What if I do? Yeah, a lot of curves. Ignoring unknown aesthetics. What if I use delta latitude? What happens? Yeah, almost the same curves. So yeah, okay. So what else do we have over there? We have polygons. So if you look at it, if we go back to the geom curve, you see the way it was telling us that you get some curves like that. Okay. Then we have the geom path. So path will follow it like that. Remember the points, it will just be plotting the points. If the points follow it like that, it will. But the path, you have lines in between them. Okay. So if we can take A and talk about paths. So A plus, and that will be geom path. A plus geom path. Okay, let me copy so that we don't waste my time. Remember we did this in that is with a B or just lines. Sometimes it doesn't give you so when you copy, please check. Okay, this one is just so A. Yeah, so this is the geom path. So this is how it is. So line and line join round, line meter is 1. You can so path. Remember, we have not added colors, nothing. All those things will come in later on. Is everybody there now? Okay. So the next one is what? So geom rect. Okay. Remember that data. Oh, sorry, we forgot about the polygons. Okay, so that will give you frequency polygon, which means this must be what? Quantitative data. And remember, the A, we were dealing with quantitative data. So to do it, we can also give it geom polygon, polygons. So in that case, we can go and copy as well. So what is happening is that now your aesthetics is what? The group. Oh, it has to copy all this. So group. So group will be the A. What I have to do head of is the economics, right? So the group must be. It has to be categorical. It was date and what was A? Let me see. And then the group, let's say, okay, let me use pop and let's see. We don't get anything. Okay, what about P survey? Okay, I should also go and check what is the economics. Personal consumption expenditure. P survey, personal savings rate. Median duration of unemployed, number of unemployed. So none of them is a group to help us get those groupings. So yeah, maybe this, but that doesn't really give us any plot. That's it's like a bat. If we have proper groupings, we should get those ones done for the groupings. Polygons. Oh, it's not correct. Was it really groups? It was, let's see. Where am I? Okay. I get. Okay, so alternatively, what I gave you is a long. They've changed part of it, so what I have printed out is different. But you can also use what is it? AE alpha. So let me try that and see. So alpha equals to that 50. Okay. So that's alpha then. Okay. Unemployed dates and so forth. So this. So you have to check geom polygon. Color related state is color fill and alpha. So alpha refers to the opacity of a geom. Values of alpha range from 0 to 1, with lower values corresponding to low transparent alpha. So okay, I think we can just move on. Okay, let's move on to those rect ribbon not quite good. So I'll move on to the line segment, which is the next one under it, line segment. So you will be doing some linear models as well. And when we do linear models, you will need some of these graphs, you need to what? Input in lines and so forth. So how do we go about this? Well, you need to know of course, if it is a line, then you must have some SY plane. So for example, A, we know that A is an SY plane, right? So A, if I want to, what I have to run A before. Okay. So if we want to fit a line, that line should maybe pass through. You have to get an intercept and a slope, right? Okay. So let's say A, we call geom AB line, which means a line, then intercept, slope. So intercept equals to, let's say, 4,000. And then slope equal to, let's say, 2 or 3. Let's just, it did not. Okay, let me see, 0.3. Because this is time series, it doesn't. It's unable to give us. But what about AB line? Instead of, yeah, let me get a horizontal line. That will make it easier. Horizontal line. So if it's horizontal line, then the y-intercept will be 4,000. Then I can take this slope off. Oh, okay, yeah. Good, yeah. So, and then I can get, you can also get a V line. V line will be a vertical line, but that will just be a slope, the year. So V line, but of course, so this cannot be like that, but 19, maybe 19. I have to go back and check. I need to delete all this. Let's say 1990. No, V line, we don't expect to get an intercept because that should be a vertical line. That's what? Ah, okay. X intercept, yeah. That's true. Instead of V, I changed it and I went to change V as well. Okay, yeah. So that should give us something like that. So we can get things like this or B. Let's look at the B, the CO data. So that one B, and then we can get geom AB line. That one is more of you have latitude and longitude. This one is not like dates. So let me just do B and then we see what it looks like. Good. So yeah. Okay, for the B. Okay. For the AB line. Yeah, that will just to be the default. That means just plot a 45 degrees line, yeah. And you won't find anything in there as well. Okay, so by here we want intercept of 0 and then slope of 1. Let's see what this looks like. Okay, so it gives us just this intercept, and of course we can do that of the V line, H line. So the end and tail of it is that you can actually superimpose lines to on plot or create a plot and so forth. Okay, so let's move on to the next one where we have continuous variables. Should we take a break or? Okay. Let's take a break and also get some water to drink.
Yeah. During the we'll be getting water. But this time we don't get water.
That reminds me of a story. Okay, so I'll show it.
Because I paid the fees. It's not no copy paste. And you have to keep these things in your head. Let's see how it goes. I have this one there, so I don't have to. The last one, that's the one you know. I have a
So So let's look at the continuous one. When we have, remember what we have been doing, that's what two variables, right? So more or less like a scatter plot. So the next one is when we have what? Just one plot, right? So if you look at what they have over there, CJ, so we go to the MPG one, and then we want aesthetics is only highway something. But remember that C, you have to make it capital. If on the sheet is C, but remember C is for concatenate, so I'm sure it's capital C. Otherwise, you have to add something to it. So from, I'll add one. So C1, then that will just be GG plot, and then data is equal to MPG. Okay, so this MPG, then my aesthetics, AEX, so actually it's X is equal to HWY. Okay, so we can do this, C1. Okay, so C1 plus geom stats or geom area so geom area, and then my stats, so the stat equal bin. I have to check what, so what is this doing? It's just like a polygon, right? So we could have gotten this, it's like the frequency polygons. Okay. Okay, we can get so C1, what should I even put over here? So create so it's the folder graphical space. Okay, and then here we add bins, more or less. That's like polygons. It looks like a polygon, polygons, but not exactly polygons, right? Okay. The next one is density. So adding densities. So in that case, we'll call C1 again. Oh, okay. Okay, so we have it in the, so you can also copy. There are minor changes in it. So this is it. But as I said, that C, it should be capital. So that's why I've just added one, because the C, normal C, you won't get C1, then we'll have C2. So what we did was the first one, if you copy, should give you something like a polygon. So if you, let me add here the polygon itself. So that will be geom Okay, so they have geom polygon and then geom frequency polygon. Let's try each of them and see what we get. Okay, this one did not work. It has to be, yeah, it has to be the frequency, because the geom polygon must be on its own. Geom yeah. Yeah, so this one will just, so the difference between this and the frequency one, this will fill it with this, like, so it's the same thing if we put them together. If you check over here. Yeah, so this fills the bin, so the bin one, it will be filled, the poly one will not add anything to it. Okay, what about the densities? That will be geom density. So the geom density and this one, the difference, this one follows the data. The frequency polygon will follow the data, but the density will smoothen it. So there you need some kind of a smoothing, like a kernel or something. So we can put a kernel, and the kernel is equal to, let's say, Gaussian. There are several kernels. Yeah. So you see, this one is smoother. It doesn't follow the frequency of the data like the other one. So the density here will smoothen the endpoints of. Then remember, we can get a histogram, right? Yes. So histogram, in the Bezier we'll just use hist, but now we need the data itself, and then we add geom histogram. So we can do it this way, or we can specify the bandwidth. Okay. We can also specify the bin width. Bin width. Yeah. Let's say 5. Okay, but if you increase it 1. So the smaller the bandwidth, the more you see the shape of the data. Yeah, it will make it even smaller. Then it looks like a bar chart, so it's not that good. So minimum should be 1. Okay, we can also get the quanta plot. Did we talk about quanta plot? Not yet. Okay, let's get quanta plot. So that will get C1 plus we call geom QQ yeah. But this you need aesthetics again. Yeah, otherwise it won't work. Yeah, because this must you have to use the same thing again. HWY. It doesn't work. QQHW1. Oh no, that's C. Okay, so I need to do C2 should be ggplot-mp3. MPG. Okay, then yeah. So this, okay, now it works. Okay, so what if I give it here? Let's see, let me try. If I give it this, okay, so it works. So this should be normal distribution. So what we mean by a quantile plot is this, that if I want to check whether a distribution comes from a particular, you've started with probability distributions with Dr. Champo. Good, yeah. So if I want to check whether a data set follows a particular distribution, I can arrange the data in ascending order, what we call order statistics in statistics. Then I can now arrange it with quantiles that I generate from that particular distribution. So this one is like a normal distribution, and then our sample, if it follows a straight line, then it fits the data. If it deviates from it, then it doesn't fit it. So that's the concept that we use. Okay, so let's look at when we have qualitative data. Check, because this, is it a C2?
Yes.
What did you do here? Rerun it. Check properly. Any question, or I can move on? Okay. Yes.
Aesthetics.
Yes.
The sample.
Yes.
I think that doesn't have the
X and Y. So with this one, it can also take a sample. So you realize that in this case, check your graph. Or did you get exactly what I got? No. Yeah, so it means we are sampling from that particular distribution. Yeah. So we won't get exactly if I rerun it again, if you put the graphs together, you realize there will be some small or slight changes in it. Okay, so let's look at the case where we have some qualitative data or discrete. No, let's look at discrete first. Discrete data. So we can use, let's say, the bar plot and so forth. So let's look at D. So D is ggplot. Let's do MPG again. The MPG, there is aesthetic, AES. There is FL, right? FL. If we check the MPG, so let me do this. So you see that it has fuel economy data. Let's check the FL. So FL is fuel type. Is that okay? So fuel type, the fuel type is of this CDEPR. So with this, I can get the bar plot, right? So geom bar, let's see what happens there. So this is quite different from our histogram, right? This is a bar plot. So geom bar. So that's bar plot. Can we move on? Yes. You are having errors. No. Check the spelling. You have to run the first one. Remember, the first one will create the So is everybody okay?
Yes, sir.
We can move on. Okay. Okay, so now let's look at two variables, both continuous. I think we've looked at some before, but two variables. So both continuous. Two variables, both continuous. Okay. So MPG, we have CT and HWY. So let's look at E, and E is ggplot2 or ggplot. Data is equal to MPG, and then the aesthetics AEX, we have X is equal to CTY, Y is equal to HWY. So let's see. It works, there's no problem. Then we have E plus. Let me do E and C. So there it is. So E plus, so for geom points, we know what will happen, right? Geom point, that it will get us what? A scatter plot. We've done that, okay. Now, what about geom quantile? It will give us lines. So let's just, as of now, we are just exploring the various geom quantile. Good, okay. So this is the first, it will actually be the quartiles. So first, second, and third. So it means that 25% of the observation will be above baseline. 75 will be below that line. The middle one will divide them into two equal parts. And the down one will divide them such that 75% will be above, 25% will be below. It's just like our box plot. Yeah, so each point that you take for X, that gives you the quantile. Okay, so.
Do you have to install the quantile?
No. Yours is not coming. Quantrig. Okay, I have it already, so maybe that's yeah, you need Quantrig. I thought it would be dependent, a dependent package, but install it. It says so.
It says you enter item from the main or 0 to 8.
Then as it says, why are you? Why is it giving you that? So please, you need to keep these sheets with you. Should they be given during exams? I don't know. The sheets, you have to print it out. At least you refer.
During exams.
No, for practice. The Quantrig.
Yes.
What does it say?
I did that. He said you should enter an item from the main.
And have you done it?
The owner. Okay, then maybe.
When you run the code, you want to install the yes or no, so just enter last name.
Yes. Okay.
Because there are yes.
If the yes has not come, you.
Because there's
Yes or no?
I wrote that one, they have passed that level. The yes or no is and I entered yes. Yeah. And it's not coming, so I have to run the thing again.
Yeah.
Run the. If you run it, if you install it, it's.
But it's like your cursor is not there. This man there. Once you get your own, now we can move on.
So, you see this one?
Yeah.
Yes or no something TV, I entered it.
Okay.
And this thing.
It's like it has not ended though. Go down.
This one is.
But your cursor is a selection. So do it again.
Access.
Yes. Press any key or
Any key.
let's see. And enter. Enter an item from the menu. Where is that menu?
I don't know what these people are trying to do. I also know they gave me and I did it long ago. See, they gave me yes or no here on a way here. And I entered yes. Yeah.
And it's repeating. Okay. Press exit. It's still the same.
0.
When you do, you have to press enter.
capital one.
No, write it on the console.
Yeah.
Yes, you don't need to go to the.
Let me see.
You want this record again.
It's still
You
can.
like as far as you want this code again. And they'll give you the real time. It's still
Ah,
installed.
install it.
It's installed.
Now it's installed. This thing.
Okay. So, yeah, we can. Quanta, you can get. So let's see what we can also, because this one has a ground, we can get lines or what we call smooth. So we can use Geom Smooth. Geom Smooth. But how do you want to smoothen it? If you need to choose one of the methods. So method, if we use LM, it means linear models. LM is linear models. There are other smooths that you can use. If you want to know all of them, you can go to the Geom Smooth. If you do question mark Geom Smooth, you will see the other methods that can be used. Like, so method. So if you go to question mark that the method you have LM, that's what we use. You can have GLM. You can have GAM. GAM will generalize additive model. You will get some curves. Or lowest. Lowest usually will give you like it will follow the data quite well than smooth. So So you see, this is better than the straight line. This lowest goes like that. Okay, so that's it. When we're able to, but this one you only be able to do it when you are doing models. Right now we have not done any model. That's why I'm just going through, just to let you know that you can fit a line, you can do this, but we are yet to do all those. And some of them, they are courses you do later on, and then you'll be able to apply some of these to create them. You got an error?
Yes.
Which one? Did you spell it correctly? You did not get it? Did you do the smooth? All of them did not come. They look. It more or less follows the data wall. Yeah, the full name is. It's more like. So in the lowest you have a smoothing parameter, and the larger it is, the more it follows the data set. If you have a model and the model follows the data set closely, it will not be smooth, because data set happens haphazardly. So if you are following it, then it's just like when we did the plot with type is equal to L. If it is not arranged, you see that it crisscrosses like that. That's how the lowest is. So you can let it be so it follows the data, or you can smoothen it, and it can eventually even become a line. Yeah, so okay, let's see what we can do more. Let's check the case where we have continuous and discrete.
Well, my
Yeah.
code is correct.
What does it say? No, there should be something attached to the error. You cannot add. Wait, you have to do the E again. So let's see what the E. Yeah, so your E is now, there's no more. So, you see, so you did something, you replace the E with something. So there. So now let's see. The case where we have one discrete, one continuous variable. Yes, one continuous variable. So discrete is like a categorical, right? So the same, there is the MPG, there is class. If you go to the MPG, there is class, which is a type of car, right? So that's continuous, right? Sorry, discrete, or when we say discrete, we mean categorical. So maybe there should be consistent there, just say categorical. Categorical. Yeah, it's qualitative, yeah, so to speak. Okay. So here we will do our GG plot. So small f d e. Okay, so I did not use capital F. Why? Why? Capital F is what? Are you sure it's a function? It's capital S F a function. It's false.
It's false.
Yeah.
The system
Knows it as false, yeah. So, okay, so now let's do GG plot. So you see the GG plot will get you the main plot, like MPG. So what our aesthetics, we are going to use X as a class and Y as what? As the, is it miles per gallon, or should we use miles per gallon, or okay, so HWY, highway miles per gallon. So we do this. So we've created F. So what kind of graph can we use for this? You have the type of cars and you have the miles per gallon. What graph can we use? Box plot, for example, yeah. We will know how the miles per gallon for each type of car. So for box plot, we also use geom underscore box.
What you did for F is like name F, right?
No, F is like the placeholder. So it creates a graph.
An empty graph.
Yes.
Okay.
So it has two-seater compact mid-size. So.
So it's like you have drawn the skeleton.
Yes, a skeleton. Yeah. Now that we are adding the plot, the box plot. There we go. So there are several of them, but we are unable to get the axis down properly. We look at it. So this is actually how it is. So if you were to buy a car, highway miles per gallon, which one will you go for? If you were to buy a car, these are the types of cars. And these are the box plot for highway miles per gallon. So if you are to buy a car that you want to travel with on the highways, and you want to get a car with that has fuel efficiency, which one would you buy? You buy which one? The SUV.
Or pickup.
Yeah, SUV. I think the pickup is the least. You this man says you buy. This one there's no items there. You are now using a strenuous variable to choose which one you buy. All we have there is highway miles per hour. So more or less the pickups were designed to go for to be used on the highways. and so forth. Okay, so let's move on. What else can we do? We can also use dot plot. You remember? Remember we did dot plot. Yeah, that will just give us the frequencies and so forth. So each of them, it will give us the plot, dot plot for each car size.
Yeah, so for a normal box plot or normal plotting question, you can use the geo function.
The normal.
There's a normal question on a plotting, like box plot or
Yeah, yeah, you can use it. Yes, yeah. I did. So when we get to the spark, we cannot be using the base. We should be using this. I mean, it goes with this one. That's why. But it's important you know the base. Otherwise, you can't maneuver your way through the basic ones. Okay. Now let's look at dot plots. So for dot plots, we are going to also call geom dot plot. Yeah, so this one we have to supply it with it's been as is. So it been as is should be equal to y. And then it has stack directory, and then stack should those be stacked across groups. So stack directory, we should say center, which means in this case it will plot it at the central part. So you hardly see this, but if you so that's the distribution of each. If you want to center it. So you can get dot charts and so forth. There's also what we call a violin charts. You know what a violin is? So we can get some here. So that we're going to also say F geom violin. Geom violin. And the violin needs scale. So scale we can use area. And there it is. So the violin plots are also very good. It's just like the box plot is to tell you how variable the data set is. And remember all this, as we move on, we'll be adding colors to it. Okay, so what happens is that when you are writing a report, you have to use variety of all graphs. Other than that, your work becomes boring, or your report. So you cannot pick a report and it is only bar charts. You want to show 10 plots and all of them are bar charts. Yeah. Whilst you can use other you have to do so. Yes. You couldn't find it. check the scale. No, you say geom plus dot plot instead of underscore. F plus geom plus dot plot. Geom underscore. So you have to select. It's still not coming. Did you see what I said? You have to check whether. No, I think something is wrong. Hold it. This I now to check. So, you. And that's it was all box. Is which one? Dot. No, something is wrong. Because it's supposed to show, then you select. But it's not showing, so. No, there's something wrong. All these are. Why is it green? If it is then it's like you see something unexpected ahead. So there's something wrong somewhere. That's what is causing all the European and that has not been good. So that is affecting all the things you are doing down there. Yeah, it should be like this. Right? Yeah, it's this one. But from here, something went wrong. And that is what is happening.
And the coach were running.
But if you mess up just one, it will affect all the rest. So it's somewhere here. Stop. So it's here. Okay, so till he says going this one too. So it is affecting all, you see now it's changing to black. So yeah. So this one, all this you did not go there properly. So it is causing. What's your double apostle? So what you did this one was alright. So it doesn't have this closing counterpart. That you see now is more. So everything. So that's the problem. So now so that's why you were not able to select. So now if you are typing it will show. Good. And then you select. What was it? Dot, right? Good. And then I think you did this. So you have to do it again. But now it should come. So when you, it will affect down the, but if you see that it's all black, then it's like black here. Okay, hey, it's time. So I think we've done box plot. We can also get, okay, so I think we've done enough. The rest is just contingency table and jitter plot. So when you go, try and also talk about the jitter plot and so forth. When you have both qualitative. When you have both categorical, you can. So for example, you have a G, FG. You have GG. G is assigned GG plot. There's a data set on diamonds. And for diamonds, you can get the cut. What is it? Cut and color. So X is equal to cut, Y is equal to color. So this one, both of them are categorical. So if you do them, and I run G, so you see color and what? Cut. But these are both are categorical. So this one we cannot really, if you are plotting, it has to be either you remember the bar plot, quantitative bar plot, or we can also get what do we call it? The count. So geom count. So here you see which cut has what higher values. So this is also a way of representing. It's like the frequencies are being plotted. So if you look at it, the larger one, which one is in the 4,000s? Is the G. Yeah. So if you look at it, this G is in the 4,000s. That is ideal cut. And then below that you have the 3,000s will be ideal. Yeah, E is also part. And then you come down. So you can use this one to represent categorical variables. Two of them. It's like cross tabulation. But instead of using numbers, you are now using circles to indicate the size. We could have also written this is 4,020 something, this one is, and so forth. So that's it. And then lastly, you can have the jittered. Is it G plus Jum jittered? We have to provide height. Wow. Yeah. Let's see. So let's see. So what it's showing you is that around the fair you have lower frequencies. So the darker it is, the more. Yeah. So this can also later on when we add colors, the color will be deepening for larger values and also lighter for small values. Yeah. So those are some of the things. But now it's all together because you don't. But okay, so I think that should be enough. Okay. Is that just? Up. Ah, okay, yeah. So it's equal to. Okay, all right. So I think that should be enough for today. We will do some more examples on it, and then next week we'll start with the SPAC, LYR.